This project is about generation of electric power using bicycles. Despite all the technological advancements around us, there are many people in this world who still lack access to electricity. A stand-alone system for power generation is required to support these people. Rising energy needs, diminishing fossil fuel supplies, detrimental effects on environment and human health caused by toxic emissions have all led to the search for cleaner and sustainable energy sources. Using human power gives a power source that is renewable. No fossil fuels are used, so no contamination of environment takes place. Unlike other renewable energy systems, it is reliable in the absence of sunlight, air breeze and water. Most commonly used designs for power generation using bicycles are discussed. In this design, bicycle's rear tire is removed along with the tube. A belt is passed over the rim. The rim acts as a driver pulley. The other end of the belt is passed over a pulley that is connected with a generator. The output from generator is regulated using a voltage regulator. A battery is used to store the power generated. This video shows the motion transfer between wheel and the generator shaft. You can see belt is used for transfer of motion. The problem with this design is that slippage losses between the belt and the rim cause drop in efficiency of the generator output, particularly so if the bicycle is operated in moist conditions. Furthermore, removing the tire for power generation and fixing it back for outdoor cycling is a time-consuming job. Thus, this design is suited to a bicycle dedicated for power generation. In the second most commonly used design, the rear wheel of the bicycle directly connects to the shaft of the generator. Motion is transferred between the wheel and the generator shaft based on the friction between them. This video shows the motion transfer between wheel and the shaft. You can see that motion transfer is through direct contact. The efficiency of the contact is relatively low due to slippage losses and frictional losses. This setup causes significant wear and tear on the tires. This may force replacement of tire every 6 months. In both the above designs, if multiple bicycles are used, each bicycle requires a separate generator. The overall cost increases significantly due to the addition of generators. The biggest disadvantage of using battery as a power storage device is that it has typical charge efficiency of only 70%. Thus too much energy is lost in transformation. Overcharging and overuse of battery can result in loss of electrolyte, thus causing battery failure. They use lead compounds which are toxic. Long-term exposure to them can cause health problems. Electrolyte used in the battery is in the form of sulfuric acid. It is highly corrosive and emits gases during the battery recharge process. It explodes on ignition and may lead to severe injuries. The capacity of the battery to recharge is reduced if it is left discharged for a long period of time. Design proposed in the next section is a novel design which aims at removing the problems identified above. A simple and modular system is designed that can be used both in gyms and at home without special mechanical or electrical skills. The main objective of the system is to get the generator to turn at maximum RPM by minimizing the power losses in the system. Next few slides show the major components used in the system. In the design, a single-speed fixed gear bike is used. The front wheel riser is used to keep the handle from moving. The bicycle trainer is connected with the rear wheel hub. It allows free rotation of the wheel while lifting it slightly above the ground. The sprocket is connected with the left side of the rear wheel hub. The chain is meshed over this sprocket and a free wheel. The free wheel rotates a shaft which rotates a scotch-yoke mechanism, in which two pistons from foot pumps are directly coupled to a sliding yoke. The compressed air from the piston cylinder action is delivered to a primary storage tank painted as blue. The purpose of the primary air storage tank is to store a small amount of compressed air for instant use in power generation while pedaling. The main purpose of secondary air storage tank, painted red, is to serve as an alternative to battery by storing compressed air for use in power generation later on. The pressure regulating valve is used to provide a steady jet of compressed air to the turbine. The air turbine contains a wheel with blades on its periphery. The high-velocity air from the tanks is impinged upon the blades of the wheel through an inlet port and causes rotation of a DC motor coupled with the turbine. The output DC voltage from the motor is fed to an inverter system which converts it into AC voltage for consumption by household appliances. Another DC motor is also connected, which is used as a benchmark to measure the performance of the system. The effect of the pneumatic accessories used in the system on the energy loss can be determined this way. In the proposed design, battery and voltage regulators have not been used, and instead, storage tanks and pressure regulating valves have been introduced. The system is more efficient if multiple bicycles are used. The pedal-driven pneumatic turbine-based electric power generation system has been proposed. Future research will be focused on optimizing the design, its implementation and experimentation.